How do you reliably compare AI models without building a custom evaluation framework? My name is Josh with RocketRide, and I'm going to walk you through how to do just that using our RocketRide tool. The cool thing about RocketRide is it's actually the AI command center right in your IDE. What that means is that you can download our plugin by just going to the plugins tab, searching for RocketRide, and then installing it directly within the IDE itself. Once that's done, you'll see a cool little rocket appear at the bottom right-hand side of your toolbar, and you'll just go ahead and open that up, and you're off to the races. So first things first is it needs to connect to our server. So what's happening is it's initializing the server and waiting for that connection to open up. Once that connection opens up, we'll be able to begin. Awesome. So once the server gets initialized and downloaded and initialized locally, we can begin creating a pipeline. So what we'll do is within the right-hand pane, the RocketRide extension pane, we will go down to the pipelines section and we will click the add button. First we need to add our project. So we're going to drag our demo project over. We're going to open the extension again. And then now we'll click the add button, which will add a new pipeline right here. Okay, so now once we have our pipeline JSON created, we are met with our canvas. And from here, our goal is to compare, we're gonna start with comparing 4 different LLM models. We're gonna give it deterministic inputs with an expected output from each. And we will also be checking the latency for each model to see how long each model takes to answer our question. And then depending on the output, we will of course be checking for accuracy as well. So let's begin. So first, we will add our chat node, which initializes our pipeline. What that means is it's going to begin our chat session, and that will also be the interface that we interact with in order to send our prompts to the LLMs. From here, we can either use the add node panel to select the LLMs that we want to work with, or we can filter the add node panel by clicking the questions box on the right-hand side of the node, just like so. And then from here, we will select Anthropic and 3 others. Those 3 others will be Gemini, OpenAI, and Grok. Let me zoom out just a little bit. And then we will connect our nodes, so our chat node, directly to each LLM. Like so. And what this will do is it will take our prompt from the interface and it will send it off to each individual LLM. And then the last thing we need to do is return the answers. So the same way we just selected our LLMs, we're just going to select the answer node on the LLMs, which will filter the add node section. And we're going to select the return answers box. And we're just going to do that 4 times. Now what this is going to do is it's going to return each answer from each LLM in its own section within the conversation. It'll make it a little easier for us to search through each of the outputs and be able to identify the accuracy and basically get the information that we are searching for. Okay, so before we actually begin the chat, you'll notice that there are 4 red cogs on the right-hand side of each LLM node. Now, what this indicates is that each of these nodes still requires some form of configuration. And I bet you can guess exactly what that configuration is. We're going to need to add our tokens. So we'll skip over that for right now, and I'll see you on the other side. Okay, perfect. Once our tokens are added, we can begin running our pipeline. So what's going to end up happening is in the pipeline section of the RocketRide extension panel, you'll see that there underneath the, or to the left of the pipeline JSON file, there's a caret. So we'll expand the caret and we will select chat. And what this is going to do is going to open up our information panel, which will give us a little bit more insight into what's happening underneath the hood. So from here, we will begin. First, we're going to select enable tracing, and you'll see why in a second. And then we're going to run and trace our chat. Okay, so now you may have noticed that that took a little longer than expected. It took almost 2 minutes. And the reason is because on the first run of each chat, it will have to initialize the packages and download them, which may take a little bit longer the first time, right? After that, every time the spin up is much quicker. So as you see, we have the chat now button in the top right of the inspector panel. So we'll go ahead and we'll click it and see what that does. Awesome. So we are now in the chat interface, which we will go ahead and actually split it to the right. And the reason we're going to do this is to give us a better view side by side of the chat itself and the inspector on the left-hand side to dig into what's happening underneath the hood. So from here, we actually have 5 preset prompts that I'm going to give it. And these preset prompts have a determined output that we expect that we can actually use to grade the responses of each LLM. So before I send the prompts to these LLMs, we're going to navigate within the inspector. We're going to navigate to the trace tab. Now that trace tab is going to give us all of the information happening under the hood between the handoff, the data at each given point of execution within the pipeline, as well as the latency or the time at which it took to execute each function. So we will paste our first prompt, which is asking what the capital city of Canada is, and we expect it to return Ottawa. And while it's thinking, we will go ahead and expand the trace and we can see exactly what's happening and what's executing at any given time. So right now we've already gone through Anthropic, Gemini, and we just got our response back. And all 4 have responded correctly or as expected with Ottawa. And we can see exactly how long each query or each prompt took in order to resolve. So from there, you might be thinking to yourself, now that doesn't really mean too much in terms of the latency, generally because there are certain things happening on the APIs of the LLMs themselves that could be making the request go a little bit longer. However, if you run this multiple times, you'll generally end up with a overall average at the end of the day. It's kind of like the coin toss equation, where if you do it once or twice, you might get heads every single time, but if you do it over 100 to 1,000 times, you'll generally get some form of an average, and that's generally the best way to measure that. So from here, we also have 4 other queries that we can go ahead and run, and we'll compare and we'll see how each LLM compares. So the next one is we are going to ask it what 17 times 24 is. And as you can see here, we now have question 2, and question 2 is being executed node by node. And there we go. We have the output for each individual LLM, which is 408, which is as expected. And we can see that it looks like OpenAI was the fastest, and Gemini and Grok seem to have been the slowest. So quite interesting. So we'll go ahead and speed through the other 3 queries as well. So here, this one is, what year did World War II end? I believe it's 1945. Yep. Perfect. And then question 3 with all of the underlying data. So we'll go ahead and we'll dig into the Grok response. See how long it took. So it took roughly 1 millisecond from Grok. Wow, that was actually really fast. And then, what is the chemical symbol for gold? We are expecting AU. And you can see the type, or the current status is processing. And perfect, we got AU from each LLM. And then our last predetermined prompt, who is the founder of Microsoft? We expect Bill Gates to be the answer. Provide only the full name of one founder, most likely the main founder. Each one came back with Bill Gates, no surprise there. And there you go. So these are all predetermined, and we also told it to return a specific format. What happens if we ask it to do something that isn't determined, right? There might not be one specific solution to this. So I will ask it to solve the Fibonacci sequence. Notice how it's taking a little longer than the others, generally because this isn't a straightforward answer. Although it's not necessarily a difficult question, it's not necessarily a straightforward one at that. Perfect. So each one came back with a completely different answer and approach to solving this problem. So starting in order from top to bottom, so Anthropic responded first, or Claude responded first, and they just output the algorithm itself along with the output, which was pretty cool. And then a definition of how it works and explaining line for line the execution sequence of each run, right? And then you have Gemini doing something similar. So it just output the solution and then dives directly into, oh, no, that's it. Gemini actually just returns the solution. And then OpenAI returns a little bit of the definition, kind of defining exactly what its thought process was. It returns the recursive function, and also it looks like an example of it running. And then the last is Grok, which looks like it's still caught up a little bit on Bill Gates for some reason, which is really funny. But it also does output that response and gives a little bit of an explanation and a little bit of an output of the actual run itself. So there you have it. We have just successfully compared 4 separate LLM models within less than 5 minutes with extreme ease of use by just chaining together a couple of nodes and chatting with a couple of LLMs. So if that helped you, go ahead and give it a try yourself by using our RocketRide tool. Navigate to the link below, our GitHub. You'll have the GitHub. We'll have the link to the VS Code extension. And give us your thoughts. And go ahead and star the repo if it helped you. And if you'd like to try to contribute in the future, We'd love to see what you come up with.